హలో స్టూడెంట్స్, వెల్కమ్ టు ఎస్వి టెక్నాలజీ. నేను మీ మహేష్. ఈ వీడియోలో మనం బీటెక్ COA సబ్జెక్ట్ కంప్యూటర్ ఆర్గనైజేషన్ అండ్ ఆర్కిటెక్చర్ సబ్జెక్ట్ వెరీ ఇంపార్టెంట్ క్వశ్చన్ రిజిస్టర్ ట్రాన్స్ఫర్ లాంగ్వేజ్ we are going to discuss. Before knowing the register transfer language, if you are watching me for the first time, please do subscribe to my channel and support me. So coming to our topic, first we will discuss what is the register, then we will discuss about the register transfer language. So what is register? Registers are smallest memory part in processor. Simply, a register is a very smallest memory unit in our computer architecture, and it is a collection of flip-flop. So flip-flop means it is a storage area where we can store either 0 or 1. Means it is a space where we can store at most 1 bit. Okay, and it is, register is collection of these flip-flop. Suppose if we collected 8 flip-flops and made together, then it is called as 8-bit register. So 8-bit register has 8 flip-flops where we can store 8 binary bits, either 0 or 1. So here each flip-flop is a storage area where you can store 1 bit information, either 0 or 1. So generally we have registers in our computer processor like 4-bit register, 8-bit register, 16-bit register, 32-bit register, 64-bit register, 128-bit register, like this. Okay, here I am going to show 4 types of block diagrams we have for register. Whenever you want to represent a register, you use one of these 4 types. So simply you are going to take a square box or rectangle box and you will represent register name in that box, like R1, R2, or we have types of register. Today I am going to discuss that also, like AC accumulator and PC program counter. Like this we give some names to register, so those names will be in rectangular box, then it is called as a register. Or we can show individual bits in that register like 0 to 7 if it is 8-bit register. Okay, if it is 8-bit register, we show like 0 to 1. Always we have to give numbering for bits from right to left side, like this. Okay, right to left side we have to give numbering, and the most significant bit is called as leftmost bit, and the least significant bit is called as rightmost bit. So in simple word, the rightmost bit is called LSB, least significant bit, and the leftmost bit is called as MSB. In future I am going to use LSB and MSB terminology, please do remember. So MSB means most significant bit, which is the most left side of the register, and LSB means least significant bit, which is right side of the register. Like this individual bits you can show here. Next, another representation is like this. If it is 16-bit register, you can show like 0 to 15 in rectangular box, then it is called as 16-bit register. And the 4th representation is you are going to make the register into half, and first half is called as higher order byte, and second half is called as lower order byte if it is 16-bit register. Suppose if you divide 16-bit into 2, it will divide like 8. 1 8 is equal to 1 byte, and 1 8 is equal to 1 byte. So first half is called as higher order byte, second half is called as lower order byte. So this is how you are going to represent a register in our computer organization and processor. Next, before going to know what is register transfer language, you should know what is micro operation. Simply, a micro operation is an operation which is performed on registered data. So already I said that register is used to store the information, right? So if you perform any operation on that particular information which is stored on registers, then it is called as micro operation. Simply an operation which is performed on register contents or registered data or registers information, then it is called as micro operation. So basically we have 3 to 4 types of micro operations. In future we are going to discuss. Okay, so what are the micro operations we have? For example, shift operation, which is going to shift register contents either left side or right side. Next, count. So it is going to, this operation is going to count the number of flip-flops or the information data, all that. And the clear is micro operation which is going to clear the data from register, means it is going to erase the data. And load is a micro operation which is going to load the data from one component to register. So these type of micro operations we have in COA subject and registers. So in future we are going to discuss in detail about these micro operations. So now coming to our actual topic, which is register transfer. Simply name itself saying that transferring the data or contents from one register to another register is called as register transfer. Simply while processing the data or while doing any programming, we have to transfer the data from one component to another component. So while transferring the data from one component to another component, registers are going to carry the data. So now transferring that data from one register to another register is called as register transfer, and it will be represented as R1 to R2. Means the data which is in R1 is going to be transferred to R2, and this arrow mark which is I represented in between two registers is called as replacement operator. Means the data in R2 will be replaced by the data in R1. So the above instructions is that data in R1 will be transferred to R2. Whatever the data is in R1 will be transferred to R2, and the R2 will be replaced by data of R1. Both the same meaning. So in our computer language, whatever the operation we are performing, that should perform under certain condition. Means that condition I am calling as P. Means prediction I call it, predict I call it, or condition I call it. In our COA subject, it is called as a control signal. So if P is equal to 1, you have to transfer this. This is what I am going to say. So whatever the transfer happens in our processor, it should happen under the circumstances of any condition. If that condition is true, what is true in our binary language? 1. If that condition is true, 1, then only this operation should perform. Otherwise, it should not perform. So it will be represented as P colon R1 to R2. What is the meaning of this? If P is true, you have to perform this operation. So this equation is called as control function. So coming to a block diagram of hardware circuit. So here I am going to show how we are going to transfer the data from one place to another place or one register to another register based on particular condition. So I have some n bits in R1. So suppose it is 8-bit register, 8 bits I have in R1 register. Now I want to transfer that n bits to R2, or I call it load that 8 bits into R2. When I have to perform that, if control unit gives the conditions and if that condition is true, then I have to load. So this is simple block diagram of that particular data. So here I have shown this clock also. What is mean by a clock? When I have to do this operation, clock means the time. It shows the time when I have to do this particular operation of transferring R1 to R2 when the P is true. So this is how I am going to show a block diagram of conditional transfer. If condition is true, P is equal to 1, then I have to transfer n bits from R1 to R2 at particular time T1, clock time I call it. So here I have shown timing diagram of that particular action. So in future, in second unit, I am going to explain about this timing diagram in detail. I am going to define what is register transfer language. So it is a system for expressing symbolic form of the micro operation sequences among the registers of digital module. So in simple terms, whatever you want to do in our computer, you have to do in the form of micro operations. So that sequence of micro operations, if you show in symbolic manner, then it is called as register transfer language. So it is basically a assembly level language. Okay. Simply a register transfer language shows sequence of micro operations. What I said micro operation. So whatever the operations we are going to perform and register is called as micro operation, right? Now if I perform an addition operation between two registers, then it is called as micro operation. And subtraction, division, all these operations I can perform on the data which is in register. If you show that operation sequences in a symbolic manner, then it is called as register transfer language. So now, for example, I am showing one operation. What is that one operation? Or not plus R1. What is the meaning of this particular operation is I am going to add the contents of or not with the contents of R1, and finally the resultant data I am going to shift to or not. This is what is the sequence of micro operations I am performing, and I am showing those operations in symbolic manner. Then it is called as register transfer language. Okay, now we will see some important registers what we have in our COA subject. These registers we are going to use in your future classes. The first one is AC. AC means accumulator, which is 16-bit register in our computer processor. So it is a processor register, and simply whatever the resultant datas, okay, intermediate datas while doing any programming process, that will store in this accumulator register. And the second one will be program counter. So this will be 12-bit register. So this is very important register in our entire processor. Why? Because it stores the address of next instruction. So you know that what is mean by a program. Program is a collection of statements or collection of instructions. And what is mean by processing? Executing that instructions one by one. So this program counter stores the next instruction address. This is the main part of our processor. While doing one instruction execution, it is going to store next instruction which is ready to execute. Okay. Next, the third one is AR. AR means address register. So it is used to store the address of a particular data. So all this register we will discuss in future in detail. So it is a 12-bit register. And DR means a data register which is of 16 bits. It is a general purpose register which is going to store data during calculation. Suppose I am doing a plus b operation. The value A is stored in one data register and the value B is going to store in one data register, and the resultant will be stored in one data register. Okay, so we will discuss everything clearly in future classes about data register also. IR means instruction register. This is also very important, like program counter. So it is a 16-bit register. It stores the current instruction being executed. So this is very important point you have to remember. So instruction register is a register which stores the current executing instruction, where the program counter stores the next instruction, but instruction register stores the present instruction which is going to be going on execution. Okay, and TR for temporary register, which is 16-bit. It holds the temporary data. While doing a process or while doing calculations, we will get so many temporary values. Okay, those temporary values will be stored in this temporary register, and after the calculation and after we are getting the result, this will be erased. INPR means input register, which is 8-bit capacity which carries input characters. And next, output register, which is 8-bit capacity which carries output characters. Okay, MBR means memory buffer register, which is of 8-bit or 16-bit we have for this capacity. MAR means memory address register, and FR means flag register, which is the capacity of 8 bits or 16 bits, used to indicate particular condition in our processor. So all these are register types which we have in our COA subject. So in next class we are going to discuss micro operations. If you are happy with this content, please do subscribe to my channel and support me. So entire COA subject I am going to do as a series. So please do subscribe and share with your friends.